Hi everyone, welcome back to Cambridge Guru. Last video was about integration that involves trigonometric functions, and we use substitution method, how we can substitute one trigonometric function with some variable and then can replace another variable, right? So next video, the next topic is about the use of partial fractions in integrations. As in further algebra, we have already done how to write a complex algebraic fraction into sum of some partial fractions. So using that partial fraction concept, and that can also be applied or that can also be useful in integrating various complex integrals. For example, that we have to find out the integral of x plus 4 upon 2x minus 1 into x plus 1 whole square dx. So as you can see here that there are no common factors from numerator or denominator, so which can be cancelled out. So what we can do here is that we write the denominator as a sum of partial fraction, and let us see whether this can be reduced to simpler integrals. Okay, so as you can see that the function x plus 4 divided by 2x minus 1 into x plus 1 whole square. This is type 3, which can be written in the form of a over 2x minus 1 plus b over uh, x plus 1 and c over x plus 1 whole square. Okay, this was type 3. So now we can form the equation, and I can directly find out the value of a because I know the shortcut method for this linear one, and there are also shortcut method for finding out the b and c constant, but we do not have to apply that. So let us first find out the value of a, b and c quickly by taking the LCM. So we have a as x plus 1 whole square, then coefficient of b will be 2x minus 1 into x plus 1, and coefficient for c will be 2x minus 1. Okay, yes, and in the LHS we have x plus 4. So here, collecting the coefficient for x square, I will get a plus this is 2x square, so 2b, right? Then we have coefficient for x will be 2a. This is 2x minus x is just plus x, so that will be plus b and plus 2c, and then the constant terms will be a minus b and minus c. Fine. Now this is x plus 4, so I can say that a plus 2b is 0 because there is no coefficient of x square in LHS. So from here I will get the value of a as minus 2b, and second equation is 2a plus b plus 2c. Substituting the value of a as minus 2b, so we have minus 4b plus b is minus 3b. I can directly write 2a plus b means minus 4a plus b is minus 3b plus 2c, and this must be equal to coefficient of x is 1. This is my equation number, I can say this is equation number 2, and a minus b minus c is equal to 4. Substituting a as minus 2b, so minus 3b minus c must be equal to 4. Okay, this is, let us say, equation number 1, this is equation number 2. Eliminating this 3b, so subtracting 2 from 1 minus 2 we are doing, so this 3b will get cancelled out, so 2c minus of minus c is 3c, so 3c is 1 minus 4 is minus 3. That means value of c is minus 1. If c is minus 1, value of b minus 1, this will be again b will be minus 1 because c is minus 1, that means this is minus 2, and minus 2 plus 1 is minus 2 in the LHS will become 2, 2 plus 1 is 3, so b will be minus 1. Yes, b is minus 1, and if b is minus 1, a will be 2. Okay, so now I have the partial fraction as or in fact the whole integral I can write x plus 4 upon 2x minus 1 into x plus 1 whole square, I think. Yes. Okay, I can write this as value of a is 2, so this is 2 by 2x minus 1. B is minus 1, so minus 1 upon x plus 1. And again, C is minus 1, so it is minus 1 upon x plus 1 whole square. Okay, yes. So now, how we can integrate this? Integrating this with respect to dx, integrating this with respect to dx, and integrating the third part as with respect to dx. Right? I can take out this 2 outside, and in the, let us consider integral number 1. I can denote this as integral number 1. This is my integral number 2, and this is integral number 3. Okay, and let us solve these part wise. So I have I1 as integral of 2 1 upon 2x minus 1 dx. Now, we have already done in the introduction chapter of integration, which was I think unit number 5, in which we introduced the integral of the type 1 upon ax plus b, whose integral involves logarithm. Okay, so integral of the type ax plus b is 1 upon a ln ax plus b. So here value of a is 2, this a is 2, and b is minus 1, right? Or you can directly use the substitution method, that you can use 2x minus 1 as t. So 2x 2 dx is equal to dt. So my integral will reduce to, this implies this 2 is outside, dx is dt over 2, so 2 will get cancelled out with this 2, so dt over t, right? It is just ln t, that means it is ln 2x minus 1. Okay, this is my integral number 1. Similarly, integral number 2 is minus of 1 upon x plus 1. Let us reject this sign, because afterwards in the final answer we will introduce this minus. I am just writing positive part as my integral. So I2 is 1 upon x plus 1 dx. It is simply ln of x plus 1, right? And integral number 3 is I3, which is 1 upon x plus 1 whole square dt. Okay, dx, sorry. So in this also we can use the substitution method, that x plus 1, let us introduce this as t. So that means dx is equal to dt. Okay, so integral now is 1 upon t square dt, which is minus t raised to power minus 2 plus 1 is minus of 1 upon t, which is x plus 1. Okay, this is my integral number 3. So now whole integral, I can write this as I is equal to I1, which is ln 2x minus 1. I2 is with the minus sign ln x plus 1. And lastly, this was minus, and again there was a minus sign in integral number 3 outside, so minus, and this minus will become plus. So this will be plus of 1 over x plus 1. You can simplify this again further, because log a minus log b property you can use. So you can write this as log of 2x minus 1 over x plus 1 plus 1 over x plus 1 plus c. Okay, and of course this plus c you have to include as a sign of constant of integration. Okay, so that's how you can use the partial fraction topic, or you can use the partial fraction concept in integrating various types of integrals, right? Here the integral was of type 3. You may have integral of type 1 also, of the type, let us say, x plus 2 over x plus 1 and x plus 2 into x plus 3. And similarly, you can have a integral of the type 2, which involves a quadratic expression without any real root, right? So that's all. In means there is no complicated questions that come in this as far as sum of partial fractions are concerned, you just have to write the original algebraic fraction in as a sum of partial fraction, and then simply either you will get a linear term here, and either you will get this. Again, you have to apply the substitution just like we did in I3. Okay, there is one you can say important formula that you will use here, that if I say let us consider x plus 1 over x square plus 4 into x plus 2. Suppose you have been given this function and then you have to integrate this. Okay, let us say that this has been partial fraction into the type of a by x plus 1 or x plus 2 plus bx over c over x square plus 4. Okay, so what you will do here is you will separate this bx plus c over x square plus 4. Okay, all right, let us do, because I have in my this PPT this type of question. So let us do this quickly. Okay, all right, so first let us write this x minus 2 over x square plus 2 into x plus 1 into sum of partial fractions. So this is a over x plus 1 plus bx plus c over x square plus 2. Okay, taking the LCM, that will be a x square plus 2a plus bx square plus coefficient of x will be b plus c, and lastly we have c. Okay, here I have x minus 2, so a plus b x square plus x of b plus c, and the constants are just 2a and c, and this is x minus 2. That means a plus b is equal to 0. Here I get a as minus b. From second we have b plus c is equal to 1, and 2a plus c is equal to minus 2. I can introduce a as minus b, so minus 2b plus c is minus 2. So combining these two equations, I have b plus c is 1 and minus 2b plus c is minus 2. Subtracting both the equation, I will get b minus or minus 2b is 3b is equal to 3. That means b is 1. If b is 1, that means c is 0. I'm getting b is 1. Okay, if it is getting c as 0, we will check, and then I have this as a, which is minus b, so a is minus 1. Okay, so now partial fraction is x minus 2 over x plus 1 into x square plus 2 is equal to, value of a is minus 1, so this is minus 1 over x plus 1 plus bx means x over x square plus 2. So let us check whether the value of c, which I am getting as 0, is correct or not. So I have this minus x square minus 2. This is x square plus x, right? X square plus x, and here minus x square minus 2. So I will get minus x square plus x square will get cancelled out. So I will just remain with x minus 2 upon. So yes, the value of c is coming out to be 0. Right, so that's how you can check also if there is any doubt in your mind that whether my calculations are right or not. Okay, so now I have this. Now I was saying before starting this example that you have to integrate this. That means you have to integrate this with respect to dx. This is my integral number 1. This is my integral number 2. Right, so let us calculate integral number 1, which is 1 upon x plus 1. So it is simply minus ln of x plus 1. I'm including the sign here, right? And then I have I2. I was talking about this I2, that how to integrate this x over x square plus 2, right? If there is no x here, so how we can directly write this x square plus 2? Yes, there is another question that we will discuss later on. So but here you can simply use the substitution as x square plus 2 as some variable t. So 2x dx is dt, that means dx value is dt over half. Okay, substituting this in this equation, dx will become dt over 2. So x dx, this is x dx is dt over half, so x dx is dt over 2. Taking this 2 outside, and this is just t, so this is half of ln x square plus 2, right? So my integral is now, final answer is I1, which is minus of ln x plus 1 plus half of ln x square plus 2. You can use the property also, that one property is that half you can raise to the power of half to x square plus 1. So I am writing this as x square plus 2 under root over x plus 1, right? Combining both the properties, that a ln x is ln x raised to power a, which is this root, right? And then log a minus log b is log a upon b, right? Plus c. This is your final answer, right? Now, in this I2, let us consider this I2. Had it been x plus 4 over x square plus 2. So, what you will do in this case? Okay, if you have to integrate this, right? Let me take another page for this. So, if you have this x plus 4 over x square plus 2 dx, so in this case, what you will do is you will separate the denominator, right? Separating the denominator means not the denominator but the numerator with the same denominator. So you can write this into two integrals. One is x square plus 2 dx plus 4 over x square plus 2. Okay, x plus 4 over x square plus 2 can be, separated, right? This is again a substitution that we have done just now, right? Using x square plus 2 as some variable. So 2x dx, x dx will be some dt over 2. So answer will be half ln x square plus 2. Now we come to this, right? So one formula that you need to remember is that integral of 1 over x square plus a square is 1 upon a tan inverse x over a. Okay, this you have to remember, right? So when we take this as our integral, 4 over x square plus 2 integral dx, so taking this 4 outside and writing this as 1 over x square plus root 2 square dx. Okay, please consider this very important, that 2 is a square of root 2, right? And I have to write this in the form of this formula, which is 1 upon x square plus a. Now if you compare this with the given formula, that x square is x square and a is root 2, right? So you can directly write the value of this integral as 4, which is our constant outside. It is 1 upon a, that means 4 by root 2 tan inverse x by a. So this is x by root 2. Okay, only this much is the difference, right? And this tan inverse formula you will get only when the partial fraction is of type b, which is of the type x square plus 2, right? Remember, in type a, type 1, right, what we have done in the part 1, that there was x plus 1 whole square, that was type 3, sorry, right? In the c type. In a type there was no square, so you won't have any formula for tan square. Similarly, in type 3 also you won't get any x square term, right? So it is only type b where you get x square plus 4 or x square plus a square term, in which you have to use the tan inverse formula, right? So that's all as far as using the partial fraction in integration is concerned. See you in the next video where we will do integration by parts. Okay, I hope you have enjoyed this video, and please mention in comments that how do you like this video, and please like, share and subscribe my channel. See you next time. Thank you.